All right, first math model semester 2 video, the study 1.1, unit 1, inverse variation. So, in looking at this lesson, I see that there are some things that may be left out or just forgotten about, but it's two things that I want you to keep in mind while you do this lesson. If you don't understand, of course, just let me know. That's why I'm here to help you. X, Y is normally how we write our coordinate pairs. Yes, it does deal with that, but the part that I want you to remember in this lesson for X and Y, which is X come before Y if you're having a hard time remembering that, that's how it is in the alphabet. But the X value is always going to be the input value, and the Y value is always going to be the output. All right. And when you think about it kind of like, think back to some of those Algebra 1 problems where you had miles per hour, or with your cell phone, you got texts per minute, or anything that kind of charges. Notice and remember that time pretty much is always going to be an independent value, because time time waits for nobody. Okay, so everything that we do is based on some time. Okay, so I mean, it could be your units or your classes completed per 6 weeks. 6 weeks would be your time. So let's see, if we talk about classes that you complete in here per 6 weeks. Well, technically, we still have some task that's being done. So you got some task to the time. Okay, but what I really, really want you to remember is that time is pretty much always going to be your input value, which is always going to be the X value. Also, the next thing that I want you to remember is that slope. When you find the slope, you're really just finding like a unit of measure. So the slope, don't forget this equation. The slope, M, is going to be y2 minus y1 over x2 minus x1. Now, you might be saying this is a little bit too much. I don't feel like doing this right now, but just know that this is some things that you may need in order to do really well on this lesson. And if you don't understand, that's why I'm here, just for you. Okay, let's get to the lesson. So the main idea of the lesson is that direct variation and inverse variation are two special kinds of proportions. So here's what I want you to know. Okay, for direct variation, definition of it, it is nothing more than a relationship. Whoops, I'm writing in yellow. Let me go and get the black so you can see better. All right. It's a relationship where one variable, variable is a constant, and that word constant is going to come up a lot. Multiple of the other. And what I want you to think about when you see a direct variation, think about a linear function where slope is a constant. Where, let's say if you went to a concert and the tickets was $50 and they charged you $5 to order it online. So 50x plus 5, 50 would be your constant no matter what. That's how much you're going to pay for your concert ticket. Think like that. Okay, so that definition that you just got right there is for the direct variation. Now, for an inverse variation, I'm going to type this one up at the top. Okay, so an inverse variation is nothing more than a relationship in which one quantity changes inversely. In which quantities, oh my goodness, quantities, I don't know what this thing is doing. Quantities change inversely. Don't let that word inversely affect you. Let me tell you what that one is about in just a second. Whoops, I ain't got no space. I ain't got no, goodness gracious. All right, sorry, English department. So that is the definition for an inverse variation. Now, What I want to do is talk about the direct variation all by itself. So a direct variation by definition is a proportional relationship between two variables whose ratio is a constant. So on this line right here, you're going to type ratio. Okay, so the ratio is a constant. Where you have the equation for it is sum output is equal to, what you get on the end, y, is equal to some constant times input. I just realized one of my examples was not the greatest, but if you got a question about it, of course, like I said, that's why I'm here. I'm here just for you. All right, and what you notice, to me, it kind of was funny, but I'm gonna tell you what I had an issue with. Ratio, when I hear the word ratio, I think of a fraction. So I had to go ahead and write this as a fraction. So what I did was I wrote it as the constant, and I want you to make note, is equal to the output divided by the input. So that's the output over the input. Whoops, that end looks really bad. All right, and when you think about it, that's y over x, or rise over run, or slope. Boom, it comes back. So description: input and output change in the same way proportionally. As the input increases, the output does the same thing. You guessed it, it also increases. All right, that's what goes right there on that line. So as the input decreases, same thing gonna happen with the output. The output is also going to decrease. All right, and if you double the input, the output is also gonna double. All right. So whatever happens with a direct variation, something is directly impacted by the other thing. So then the other thing is that the size is going to change, but the shape does not. And it's going to make sense in a minute. If you looked at the lesson that they had on Apex, then what you see was the rectangle, and they talked about how the rectangle changes. And also what's important is that we look at the graph. The graph of a direct variation, the equation is linear. So the graph is also going to be linear. All right, it's going to be a line. I said linear. The graph is a line. So that's that. Now let's talk about inverse variation. Okay, when you think about inverse, that word in and of itself is just opposite. So things are going to change. Everything that we did for direct is going to be the opposite for inverse. So instead of dividing with a ratio, here we're going to use the word for multiplying, which is product. So an inverse variation by definition is a proportional relationship between two variables whose product is a constant. So before we was multiplying, this time we're going to go ahead. Before we were dividing, this time we're going to multiply. So multiplying just is product. P-R-O-D-U-C-T. All right, there we go. And before we had the output was equal to the constant times the input. And this time the output is equal to the constant divided by the input. Now, to me, I'll be honest, once again, that didn't make sense to me. So I had to make it look like what the definitions say. So I went ahead and solved for the constant. And if you're struggling with solving for the constant, that's okay. Once again, that's why I'm here, to help you. So the constant is actually going to be equal to the output times the input. Okay. And that's that for the equation. Now, the input and output change in opposite ways proportionally. So here's what I need you to see. With a inverse, once again, we're doing opposites on everything. But see over here, for direct, it was the same. So as the input increases, the output is going to do what? Haha, you guessed it. It's going to decrease. Decrease. Look like I'm typing in purple. I'm sorry about that. Let's see. Yep, I can make it black. Boom. All right. So as the input decreases, the output is going to do the opposite. It's going to increase. And we all like a little increase, especially in our bank account. All right. If you double the input, the output, instead of doubling something, instead of me having 2 times, I'm going to have half that value. So I'm going to just go ahead and write that one. So it's going to be half, or H-L-H-A-L-V-E-D. All right. So the shape in this one is going to change, but the size is going to stay exactly the same for an inverse variation. Okay, and for our equation, instead of it being linear or a line, the equation is rational. So the graph is going to be a curve. Best way to describe that graph is a curve. Okay. So here comes the main idea again. If you know an input and output pair for a direct or an inverse variation, you can find the constant of variation. Now, we're going to use the given information below to find the constant. Don't worry about us not having enough space over here, because what I did was I went ahead and I put it on the next slide. And so here we go. Direct variation with a width of 10 and a height of 5. So we know that our equation is output is equal to constant times the input, where the height is going to be 5. And so I'm just plugging in what's given. I know that the height is 5. So right here, I'm going to put a 5. So 5 is going to be equal to my constant. I have no idea what it is. I'm calling it x. And my width is given in the problem also. So x times 10. All right, solving for x on my constant. I know if x is multiplied by 10, then I need to go ahead and divide both sides by 10. That's the only way to get x by itself. And in this case, 5 divided by 10 is going to be a half. So my constant here is a half. Keeping it moving right to the right side of it. An inverse variation with a width of 10 and a height of 11. Knowing that the output is the constant over the input. So my output is the height, the constant, and then we have divided by the width, which is my input. So my height is given is 11. So I'm going to set this up as 11 is equal to my constant. I don't know. I call it x divided by the width, which is 10. I am just going to cross multiply because it's divided by 10 here. I can just cross multiply if I put that over 1. Anything divided by 1 is just that number. So I'm left with x is equal to 110, and that's going to be my constant over here. Keeping it going, I got an inverse variation with a width of 10 and a height of 7.5. Don't let this bother you. That's why I went ahead and highlighted both of those in yellow, because you're actually going to use this same exact equation, which inversely is going to help you use this equation right here. So the height is equal to the constant. Whoops, I should have put that in yellow. The height is equal to the constant divided by the width. So let's go ahead on and plug that in right there, okay, because it's another inverse variation. So my height, 7.5, and my constant, I have no idea. I call it x. That's going to be divided by my width, which is 10. Once again, put that 7.5 over 1 and cross multiply. In this case, x is going to equal 75. That's going to be my constant. And then same thing over here, direct variation highlighted in purple. Got my purple right there. Boom, doing the same exact steps. Here it, whoops, I used the wrong thing. Here is my equation, which is the height is equal to the constant times the width. So let's go ahead on and plug it in and go to work. So the height here given is going to be 3. So I'm going to have 3 is equal to my constant. Have no idea. Call it x times the width, which is 3. Well, if x is multiplied by 3, I know to get x by itself, I need to divide by 3. So x is just going to be 1. My constant is 1. And so here we go with a question. What are the two general forms of the direct variation equation? I'm going to write them in purple since that's direct variation. So y divided by x equals k. And also you can write it if you solve for y, which is always your output. Y is equal to k times x. They just went ahead and cross multiplied that first one. And then the next question asks you, what are the two general forms of the inverse variation equation? So inverse variation is going to be y is equal to k divided by x, and whoops, look at that handwriting. Ooh-wee, beautiful. Y times x is equal to k. There you go. All right. And then the last question, summarize and answer each question. It says, what steps can you use to solve a variation problem? There are a total of 5 steps. And to help you, I'm going to go ahead on and type these up, because if I write it, I got a feeling on this thing, you would not understand what it is I'm trying to tell you. So the first thing that you got to do is you have to determine the type of variation. There we go. So that's step 1. Determine the variation, the type of variation. Then step 2 says to determine the constant. Whoops. Determine the constant. There we go. And step 3 says to write the equation. All right. Whoops. I didn't put a 3 there. Let's put a 3. Boom. All right. And number 4. Told you they got 5 steps. Substitute the known value or values. So substitute the known values or value. All right. And step 5. Guess what it is? Boom. We're trying to solve this thing. So number 5 is going to be solve. All right, and there you go. Okay, so the next question in summary is, how do these steps change when the constant is not given? So once again, I'm going to type it up, because if I write it, you ain't going to understand it. So we start very similar to the last one. We're going to determine the type of variation. And what I notice is that with these problems in practice, they go ahead and tell you what type it is. So that's pretty good right there, because you know how to set up the equation or what equation to use. Okay, step 2, it says to write the general equation. Boom. All right, and then step 3 says to determine the constant. Whoops. C-O-N-S-T. There we go. Boom. All right, step 4 says to write the specific equation. Step 5, yep, this one got 6. It got an extra one, and that's all good. We are going to substitute the known value or values, just depends. And then number 6, boom, guess what we're going to do? Yep, you guessed it. We're going to solve. All right, and that concludes our lesson 1.11 on what is it? Indirect variation. What I want to encourage you to do is look at the practice problems. Of course, if you have a question, that's why I am here, to help you. Okay, good luck with your lesson and also with your quiz. Thank you.